The Haber-Bosch process, developed in the early 20th century by Fritz Haber and Karl Bosch, stands as one of the most consequential technological achievements in human history. It is the industrial method for synthesizing ammonia, NH3, from atmospheric nitrogen, N2, and hydrogen, H2, effectively teaching humans how to fix nitrogen from the air. Before this breakthrough, the world's food supply was limited by the availability of fixed nitrogen for fertilizer. Natural sources, such as guano deposits or sodium nitrate mines in Chile, were finite and could not sustain a growing global population. In 1909, the German chemist Fritz Haber succeeded in the laboratory where others had failed. He demonstrated that nitrogen and hydrogen could be combined under immense pressure, around 200 atmospheres, and high heat, about 600 degrees Celsius, using an osmium catalyst to produce ammonia. However, Haber's achievement was a laboratory-scale proof of concept. The challenge of scaling this delicate, high-pressure process for mass production fell to Karl Bosch, an engineer at the German chemical company BASF. Bosch and his team overcame monumental engineering hurdles. They designed the first large-scale high-pressure chemical reactors and developed a method to produce hydrogen on an industrial scale. Crucially, they sourced a more practical and cheaper iron-based catalyst, replacing Haber's rare and expensive osmium. By 1913, the first full-scale ammonia plant began operation in Eppach, Germany. The impact of the Haber-Bosch process is twofold. Initially, it allowed Germany to produce explosives for World War I without relying on imported nitrates. However, its true legacy is in agriculture. By enabling the mass production of affordable nitrogen fertilizers, the process unleashed a green revolution, freeing humanity from the constraints of natural nitrogen cycles. It is estimated that nearly half of the nitrogen atoms in the average human body today come from this synthetic process.